Hi, with the proof of the Coarea formula, Sard's theorem, and the implicit function theorem completed, I thought maybe it's a good moment to stop and do a self-assessment of how well we have been presenting these stuff and how well you have been receiving them. So I prepared a total of 7 questions that I made into true-false format. First, if there is nothing else specified, we will always be going from Rm into Rn, where m is larger, with the Lipschitz function f. The first statement is that if you begin with a measurable set in the domain, then its image will be measurable. Maybe you want to take a few seconds to think about this. You are always free to pause and maybe draw a picture to figure out some of these. But once you're ready, 1, 2, 3, the answer to this is false. And if you got it wrong, then don't kick yourself, because the first edition of Evans and Garip's book overlooked this and claimed this to be a true statement. However, it is not. And then they corrected it in the errata and also in the second edition. So the most compelling counterexample I can give you is consider Rn sitting inside Rm. Take any non-measurable A in Rn. As a subset of Rm, it is measurable because it has Lm measures 0. But under the projection map pi, pi of A is not Ln measurable because it is equal to A, and we started with a non-measurable set. So that ends the story there. The second statement, if your map is surjective, basically this is saying if you cover an open set, then the rank of the derivative must be the maximum possible on a set of positive measure. So if you want to span, say, sweep an n-dimensional area, then your derivative must have full rank on a set of positive measure. Your Jacobian must be positive on a set of positive measure. True or false? Again, free to pause. The answer to this one is again false. And this is not easy, and the example we discussed through these videos was that due to Kaufman, where he gave an example of a map from R3 into R2 that is C1 indeed, better than Lipschitz, and it's onto, but it's critical, so rank of the derivative of f at x is less than or equal to 1 at every x, because it's continuous, the derivative is continuous almost everywhere, is the same as everywhere. So that's not an easy counterexample, but the statement here, the true version of it, is quite important. Statement 3, if you start with a null set in the domain, then for almost every point, the level set above that intersects this null set on a set of measure 0. The measure being the Hausdorff measure of m minus n. Okay, true or false? Do you see a way? Think about simple case of, again, projection map and Fubini's theorem. Is Fubini's theorem trivial for null sets? The answer is no, but the claim here is actually true because of the Coarea inequality, and I don't know of any other way of obtaining this without using Coarea inequality. Statement number 4. The Coarea equality is needed in proving that this function is measurable for every measurable subset of the domain. So the key word here is needed. Can we prove this measurability without the Coarea inequality? So it is needed, so it makes this statement true. Indeed, one of the key uses of the Coarea inequality in the proof of Coarea formula is just to prove this measurability. You prove for compact sets A, and then you approximate arbitrary measurable sets by compact sets. In doing this approximation, you lose a null set, and you need the Coarea inequality together with the previous statement to take care of that remaining null set. 3 more to go. If f is C infinity, then the fiber, the level set, is a manifold of the right dimension for every point in the range. True or false? Think about your favorite C infinity functions. Is the preimage of every point a manifold? If you've seen the pictures, the animated pictures that I showed in the first video, you probably know the answer immediately. And the answer is false. The counterexamples, the stupid constant functions. But if you want maybe a less boring one, go with the f of x equal absolute value of x to the power 2, which goes from Rn into R. Then c equals 0 is a problem point because it's preimage, it's a singleton, not of this dimension, and for every other point though it is true. And that follows from Sard's theorem that this will be indeed a manifold, but you have to sacrifice a null set of z's. Okay, statement number 6 finally is the Coarea formula for a particular function. If you have a continuous function with compact support, basically I want to avoid saying integrable L1. Then you can integrate it by first integrating against the Hausdorff-1 measure along the diamonds. So this diamond and then this diamond, although I messed up my diamond. So an increasing sequence of diamonds. These are A is parameterizing these diamonds, so this will be at distance A. True or false? First integrate over the fibers and then add up. If you want to write this as the Coarea formula, you must declare this as your function f, which goes from R2 into R. So those diamonds are preimages of this function. So this is just level set above A. And in this format, this side is exactly what Coarea formula says. This side though is missing some important element, and that is the area factor. Here will be C1 of derivative of f at x. Here xy, like our x is a vector. And in the example videos I made, we computed this Coarea factor for this particular example, and it's always constant root 2. So if you multiply by root 2, then you have the right equality. So if one day you desperately need to integrate a function first along the diamonds, then you can use this. Okay, the last but not least is claiming that C1 regularity is sufficient to rectify the level sets of a Lipschitz function around points where its derivative has rank n. So these 4 level sets after a C1 diffeomorphism. So this transformation was this, there exists a C1 map from Rm into Rm. Well, from open neighborhood of Rm to Rm. When you compose F with this diffeomorphism, then the new level sets become straight vertical subsets of Rm minus n, rather than being arbitrary looking back here. So a neighborhood of x0 can be C1 transformed to this, so simultaneously all fibers become rectified. True or false? Is C1 enough here, or you need more? The answer is, this is a true statement. You need more regularity for Sard's theorem, but for this particular, say, constant rank theorem, submersion theorem, we call it implicit function theorem, you don't need more regularity, so C1 is enough. If you like this video, if you've been liking the videos I've made, please subscribe to my channel. If you want any changes, please do put them in the comments, and see you in future videos.